Hello and welcome to the latest edition of the Reimagine Mobility podcast series. I'm here with Guido Bairati from VI Great. And Guido, explain a little bit your background, where you're coming from. Explain what VI Great provides and does in the mobility space. There's quite a bit and a very important message I'm sure that you have there for our listeners and viewers. And then let's jump in and reimagine mobility together here as we look into the future and also a little bit to the past and where we've come from.
Thanks, Stefan. Thanks for having me here today. It's a pleasure. Yes, as you say, my name is Guido Bairati. I can say that I spent my entire career in the simulation world. I started back in 1995 as a technical consultant at the Volvo car in Sweden. I was working at the simulation department. Then I worked as a software developer for a company called Mechanical Dynamics. That was the company developing Adams, which was and is still the leading software for multi-body simulation. And then I moved to a sales role at MSC Software, where I took care of all automotive customers in Italy. Then in 2008, I joined VI Great. VI Great at that time was a small startup, and I actually contributed to its growth from a small startup company to the point when we sold the company to Spectris in 2018. And during that acquisition, we joined HBK. And now I'm a managing director of VI Great within the HBK Virtual Test Division. At HBK, we are helping our customers accelerate their product innovation across the virtual and into also the physical and in-process testing. And specifically, VI Great belongs to the virtual test division, and therefore we are helping our customers in the transition from physical testing into virtual testing with simulation software, with simulators, and with hardware-in-the-loop techniques. Primarily, we are working in the automotive industry, and the automotive industry is going through a major revolution, I would say major disruption. And but at the end, despite of the new challenges, everybody has the same needs. Decrease the time to market, decrease the development cost, and developing innovative products. And thanks to our software and our driving simulators, we are actually helping our customers to be more productive in their development process.
Very good. Great summary, great background. Let's start right at the beginning that you mentioned Volvo. So my 20-year-old daughter told me the other day she's going to buy a Volvo as her next car and I said, well, why? Why Volvo in the US? Volvo is not necessarily the top brand, right? And she says, well, because they're the safest cars. Okay, that's a good statement and certainly appreciated. Let's take safety as a springboard. At VI Great, you have some great simulators, as you just mentioned, and simulation technologies.
Yes.
What is the most important thing that you guys are looking for to help a OEM or a supplier of components that could use one of your simulators? Is it that you can test more in a shorter period of time? Is it that you can test more corner cases and use cases than you could in the real world? Is it the ability to consistently make upgrades on an almost daily basis instead of having to wait for test results to come in from the real world, from a test track? Highlight a little bit where simulation tools and, as you mentioned, hardware-in-the-loop tools are really helping the mobility space as we reinventing ourselves, as we go through this disruption, as you just mentioned, and as we progress into the future and reimagine mobility.
I would say all what you said is true, and we do almost everything you said. We, thanks to simulation and simulators, our customers, who are primarily automotive OEMs, tier one suppliers, engineering service providers, racing teams, and universities are actually able to build a virtual copy of the car or the component that they have to develop, and actually getting answers, getting results even before the first prototype is built. And that is what the simulation does since 20, 30 years. With driving simulators, I think we made another step forward. We allow our customers not only to study the behavior of their vehicle virtually, but also to get a subjective feedback. So we allowed a professional driver, a human being, to actually drive a virtual prototype and giving feedback to engineers. So basically what we have done is that we allowed engineers, simulation engineers and test drivers who have been historically two separate departments, two separate worlds, working together and actually working faster together. So we actually allow customers to have a very quick, agile development loops in which a virtual vehicle model it's developed. The test driver drives it on the simulator, gives feedback, the model is modified, and the driver can test immediately a new version. I can tell you that sometimes modifications are done while the driver is still on the simulator. It doesn't even have to get out of the simulator to test a new car. So one of the main advantages of this approach is that things can be done much earlier in the development cycle, but also more solutions can be tested, because you don't have to build a new prototype, you don't have to build a new suspension, you just modify a virtual model, you just modify a file. To test 10 different tires, you just have 10 different files, and you just test those files.
Okay, perfect to explain it. So Guido, then let me ask you this. You talked about faster, you talked about an incredibly fast feedback loop, so to speak. I give you feedback on how I'm driving in the simulator, you're already adjusting it. And on the next curve that I'm taking, I'm already have the adjusted parameters, so to speak, right?
Exactly.
Give us a little bit of an idea from a quantified perspective. How much faster are OEMs to develop or validate or create a function with your simulator than without? So was it before a 2-year endeavor to create a vehicle that has a nice radius that it takes in a turn, and the chassis dynamics and vehicle dynamics work very well? Now with your simulator, that 2 years has turned into only 1.5 years. Give us a little bit of an idea. What do these tools truly help? Obviously, besides, again, an infinite amount of data collected and used again in the digital twins, but how much faster is your technology able to allow OEMs or tier 1 suppliers to develop new technologies?
I mean, it's a very good question, and I have a specific metrics from our customers, which I want to mention because those are metrics that are publicly available. A few years ago, Volvo declared that thanks to the usage of the driving simulator, they managed to decrease by 50% the development time of their SUV. Recently, Ferrari said during one of our user conference that we are organizing annually, that right now, thanks to simulation and simulators, they are able to predict virtually 98% of the performance of their car. That means that when they build the first prototype, they just have to do a fine-tuning to reach the desired 100%. Recently on LinkedIn, Bridgestone published a very interesting video in which they say that thanks to a virtual approach, they have reduced the physical testing by 80%. And another customer, which I cannot mention, told me that 1 week at the simulator, it's worth 4 weeks on the proving ground. So you can actually say, if I'm not wrong, that you have a 75% improvement. So it doesn't matter if it's 50% of Volvo, 98 of Ferrari, 75 or 80. We are talking about double digits improvement thanks to a virtual approach. So our goal is to help our customers to build the first prototype right, almost being a ready for production car. We always say that our mission is to help our customer win the zero prototypes challenge.
Those are incredible numbers, Guido. So then let me ask you this. Again, this is a podcast about how we reimagine mobility. So with 50% being the lowest number you've mentioned here, and your stated goal of helping your OEM customers to get to a zero prototype vehicle situation, which, by the way, as we all know, many OEMs have declared that as being their goal.
Yes.
How much longer is it taking that we get this 50% to, let's not quite go to 100%. I struggle with really seeing 100% probability here in all virtual, but whatever, 90+%.
Yeah.
What are we talking here, Guido? Are you seeing this happening in 2 years? Are you seeing this happening in the next 5 to 10 years? What is it that you see as we look into the future here with this?
It depends a lot from company to company. I have to say, Stefan, that some companies are already very close to that target. And by the way, I agree with you. There will be always the need for some physical prototypes, of course. At the end of the car needs to be tested. But we really want to decrease the number of physical prototypes. And some companies are already there. Others are not there yet. So if you ask me when globally the automotive industry will reach that target, probably in 5 years, but I can tell you in some companies, especially in Europe and in North America, this is already a reality. And I didn't mention that, but the discipline that we help our customer to study with our solution are typically vehicle dynamics, ride, comfort, and the age. So we help them to study how the car handles, how the car rides, how the car sounds. But since we are talking about innovation, now more and more our customers are using simulation and simulators and virtual reality technology for ADAS, for autonomous vehicle, and also for the so-called HMI studies to see how the driver interacts with all different, devices, infotainment system that we have in modern cars. And there you can imagine the advantage of having the possibility to switch from one dashboard configuration to another one without actually building that dashboard configuration physically.
Very interesting. So Guido, that brings me to an idea. In the US, and we have different types of organization in Europe and in Asia as well, but a company such as J.D. Power and Associates, for example, that tests consumers' impression of vehicles. Do you already have customers that use your simulator before they even develop a vehicle or decide to develop a certain feature set for a vehicle, that have consumers or potential consumers use the simulator to give the OEM feedback on how, you just mentioned, the HMI impacts them, the lighting impacts them, the ride and drive, the NVH, all of those parameters or characteristics you just mentioned in place?
Yes. Earlier I mentioned that we allowed the professional drivers to work with engineers. But there is an increasing number of companies who want to use the driving simulator also to expose the future product to potential customers and to do psychological studies, see how they behave. So more and more common people, common drivers like you and me, are exposed to a driving simulator to provide feedback in an earlier phase when changes can still be done. You know, if a large OEM asks now a potential customer to drive a car, and then they get a negative feedback, they have a little possibility to change the car because very likely they are at the late stage of a development cycle. But if you can do that much earlier, 1 year earlier, 2 years earlier, then you can get valuable feedback which can be used in the development to develop a better car.
Right, right. Amazing. So again, maybe a little bit more of a provocative question, my next one here. And again, truly focus on as we reimagine mobility. With the onset, or really now it's not the onset anymore, but really starting to hit this first high point of usage of AI in the automotive space. We don't, in 5 years, do we still need a simulator, or will AI have pretty much all the data, gather the data, and be able to configure what we just talked about, a physical prototype based on digital data and consumer preferences that the AI algorithm collects from Europe to certain countries in Europe to global, etc. Will an HIL, will a simulator like what you guys are doing right now still be needed, or will it be replaced truly by software and software only in the form of a major AI initiative here?
Well, AI is undeniably getting more and more visibility and importance. I was personally, 2 months ago, I was at the CES in Vegas, and everything there was about AI everywhere. And definitely artificial intelligence will help us and our customer to better analyze the data that are generated. But at the end, the cars will always be driven by human beings. So I strongly believe that the subjective feedback will always be important. The human factor will be important. Therefore, at the end, it's important that a driver, no matter if it's a professional driver or a common everyday driver, has to go on a simulator and test it and give his feedback. Personally, even on autonomous cars, even if we will not drive those cars physically, the human acceptance of those cars would be extremely important. And in order to develop autonomous cars which would be accepted by us, by the majority of the people, we need to make sure that when they are on an autonomous car, they feel comfortable.
Agreed. Slightly different question, Guido, for you, and interested in your perspective, because one thing I often do, even within AVL, where we have obviously a simulation organization, but also when we talk to potential customers and suppliers, is this topic of correlation, right? How well does the simulation tool, or in this case, maybe an HIL, a driving simulator, correlate to the real world? I know 20 years ago, or maybe even more now, when simulation tools came more into the form as we know them today, correlation obviously was very, very low. But over the last several years, this has tremendously increased to the point, as you shared before, that we can start talking about truly a zero prototype world, because the reality and the digital twin are so close together.
Yes.
2 questions for you on that. How close is it together now? Are we within 20, 30% of what reality is? Are we already within 2 or 3%? And then what are we going to see over the next couple of years or next 5 years, again, as we reimagine mobility and discuss this topic here?
We are in the range of few percent, sometimes 1% or less of 1%. Of course, in order to reach those results, you need to have a good simulation models. And in order to have good simulation models, you need to have good data. Otherwise, if you don't feed your simulation model with good data, you just get what you input. But with good data, 1%, it's normal. And here, I think it's very important that OEMs, engineering service providers, and the suppliers are working together. Because at the end, a car, like a real car that is assembled with tires coming from one supplier, the steering system from another one, brake system from another one. The same happens in the real, in the virtual world. And more often we observe that OEMs are working on a simulator with suppliers. Very often tire companies are working with OEMs in order to improve the simulation models on the simulator. And they really work, some years ago they used to meet at the proving ground and to test the 10 or 15 tires I was mentioned before. Now they more and more often meet in a simulation center where the tire supplier, instead of rubber, brings tire property files, are files with the tire properties, and then the OEM brings the vehicle model. So this integration, this collaboration between suppliers, universities, and OEM, it's key for advancing the quality of simulation models. And then of course software vendors like AVL, like VA Grade, like a lot of other companies are continuously improving the quality of their models. Think about tire models. Mathematical tire models have increased dramatically in the last 10-15 years. 15 years ago, to perform a 1 second of simulation, you had to wait 10-15 minutes. Now those tires run in real time on a simulator. So things can only improve with the improvement of software, with the improvement of hardware. Hardware is getting always faster and faster, and with a better collaboration between companies.
Completely agree. Two more questions, Guido, for you. So the one you kind of maybe already alluded to a little bit of what you're kind of looking for going forward, but what are some of the technologies that you're mostly excited about happening in your space, in the simulation space, or maybe in the driving simulator space, that you're going to see happening over the next 2 to 5 years? What would that be?
Two comes to my mind. One it's virtual and augmented reality. We are just at the beginning, but this is going to give us a lot of more possibilities. I just mentioned before the possibility of running different HMI studies. If you have a virtual reality headset, you can just project a different dashboard, a different set of screens, and you can see how the driver interacts, and also how he gets distracted eventually by all those devices. That is a technology that is just at the beginning, and I think he has a huge potential. The other one is something that we are developing at the VI Grade. So what we are doing now, it's really to try to give the customer the possibility to experience all different attributes, all different disciplines at the same time. So we call it a multi-attribute simulation, where a driver on a simulator can experience how the car handles, how the car rides, and also how the car sounds at the same time. Because in the past there were simulation programs and simulators fully dedicated only to vehicle dynamics or ride or NVH. And what we are doing at VI Grade, it's really to unify that and give a unique experience to the driver, which is actually what you experience when you drive your car. At the end, you experience all different disciplines, low frequency, high frequency, sound, noise, vibration at the same time.
Very interesting. So maybe the next step should be then also smell and the wind, maybe when the window's down and all these, but I'm sure you guys going to get there.
Yes, that is part of the subjective experience. We haven't done anything about that, but it's definitely around the corner.
Very good, very good. And very last question for you, Guido. What is the next car you're going to buy and why?
Oh, well, a good I don't want to just name a specific brand. I think my next car will be definitely an electric vehicle. I think the path is signed, and the automotive industry is going in that direction. There are still some uncertainty how quick the transition to EVs will happen, but I think it's going to happen, and it's around the corner. And you know, I was a couple of weeks ago, I was in China, and you know, those guys have already made the transition. And for example, in the country where I live, we're a little bit behind, but it's coming. It's coming. So definitely an electric vehicle.
Absolutely. And I know in the country that you're living, there's a lot of different types of options you already have, from a luxury vehicle that's electric to a sports vehicle that's electric, and to a more general purpose vehicle as well. So thank you very much, Guido. This has been very interesting, not only for me, but I'm sure also for the listeners and viewers that will see this. The insight here of what you guys are doing at VI Grade, and certainly what real world simulators and together with the digital advancements and digital twins can do for the automotive space. Thank you very much.
Thanks for having me today. Thank you. It was very interesting and a pleasure.
Thank you, Guido.